Alright, so let's consider this other question to explain Laplace transformation. The question says, determine the Laplace transformation of the function f of t equals 4t exponential minus t. So we're given the function f of t to be equal to 4t exponential minus t, and we're asked to evaluate the Laplace transform of this function. And we know that the Laplace transformation of any function, in this case now, 4t exponential minus t is equal to integral from 0 to infinity of the function, which is now 4t exponential minus t multiplied by exponential minus st dt. So this is the Laplace transformation of any given function. Again, I have an exponential term or two terms multiplying themselves. So what do we do by indices? Pick one of the exponential term and what? Add up the powers. This is now equal to integral from 0 to infinity of, this becomes 4t exponential, adding up the powers, I have minus t minus st, okay, times dt. Again, 4 is a constant, always put 4 out of the integral sign. So this is equal to 4 integral from 0 to infinity t exponential, okay, of course, minus and t is common here, so I can factor out, it becomes minus 2 minus 1 plus s multiplied by t times dt. So this is our integral. Hence, we need to now evaluate this integral. Integral t exponential minus 1 plus s times t dt. So let's do that over here. Okay, so please mind you, I'm keeping this 4 and I'm working with this integral first. So at the end of the analysis, we can now append 4 to it. So this is now, we are looking for the integral of 0 to infinity t exponential minus 1 plus s times t multiplied by dt. And this is product integration. Once again, we'll use the integration by parts formula. What is integration by part formula? Integral of u dv is equal to uv minus integral of v du. This is integration by parts formula, where u always remains the given function and dv remains the exponential function. So the given function now is t, and dv now remains this exponential what? Function. Alright, so simply u is equal to t and dv is simply what? Exponential minus 1 plus st times dt. This remains our dv. So from the formula, we need to find what? Du, and we need to find v. Du is obtained from what? In differentiating u. So if I differentiate u, du, I'm simply going to have what? 1. Okay, but since I differentiate u with respect to t, it becomes what? Dt. So du is simply what? Dt. Since t here is raised to the power of 1, hence du becomes dt. Similarly, to find v, I have to what? Integrate this function. V is simply by integrating exponential minus 1 plus st times dt. That is the only time I can get v, by integrating the v. So this simply implies, if I integrate that function, I'm going to have v by integration. Remember, to integrate an exponential function, I've always said in my videos, differentiate the power first. Use the derivative to divide the exponential function. That gives you the integral. The power is minus 1 plus s times t. If I differentiate this with respect to t, I'm going to be having minus 1 plus s. This is what I will be having, because t here is to the power of 1. Now, use this result to divide the exponential function. So it becomes exponential minus 1 plus s times t all over minus 1 plus s. I have this. It's as simple as this. So this becomes my v. This is the integral of that function. Alright, so I can send this negative sign up. V becomes minus exponential minus 1 plus s t all over 1 plus s. Mind you, I move this negative sign up, so which is here. Alright, so that's our v. We can now plug in those values into our original equation, or the equation for integration by parts. Now I'm solving all at once. This is now integral from 0 to infinity t exponential minus 1 plus s t dt, and this is equal to, this stands for this. So we said u times v. What is u? We said let u be equal to t, so you put it down, t times v. What is v? V is simply equal to this, minus exponential minus 1 plus st all over 1 plus s. Okay, that's our v. Okay, minus integral v times du. Again, what's our v? V remains this, minus exponential minus 1 plus st, okay, all over 1 plus s, multiplied by du. What's our du? Du equals to t, so multiplied by dt. You simply have this. All right, so this is integral from 0 to infinity t exponential minus 1 plus st times dt, and this is equal to, rearranging this now, it becomes minus t exponential minus 1 plus st all over 1 plus s. Okay, observe that minus times minus becomes plus. Again, 1 over 1 plus s, or this 1 plus s under here is a constant, so you can pull it out. It becomes 1 all over 1 plus s, integral of exponential minus 1 plus st times dt. Again, we need to integrate this function. So this will be equal to, we keep our value here, minus t exponential minus 1 plus s t all over 1 plus s, okay, plus 1 all over 1 plus s. Now, if we integrate exponential minus 1, okay, 1 plus st dt, if we integrate this function just like I explained here, this also stands for this. We are going to be obtaining this same result. Differentiate the power to integrate an exponential function, differentiate the power, use that derivative to what? Divide the exponential function. So which is exactly what we have here. So if we carry out this integral, we are going to be having minus exponential minus 1 plus st all over 1 plus s. So we simply have this. Okay, all right, so not forgetting the limits, this becomes integral from 0 to infinity t exponential minus 1 plus st times dt is now equal to, now we append the limit. This is minus t exponential minus 1 plus st all over 1 plus s. All right, so let's expand now with this bracket. This is plus times minus becomes minus. Again, 1 plus s times 1 plus x here gives us 1 plus s all squared. So this is now equal to minus exponential minus 1 plus st all over 1 plus s all squared. So we'll put in our limit from 0 to infinity. Now, evaluating with the limit, upper limit comes first. Always upper limit minus lower limit. So let's put in the upper limit. Wherever you see t, you put in the upper limit. I have minus t. T is here, hence upper limit is there. Hence upper limit becomes now minus infinity in place of t exponential minus 1. Okay, now I have 1 plus st. T is also there and t is infinity, so it becomes infinity times 1 plus s. Okay, all over 1 plus s minus exponential, I have 1 plus st here, and t there is the infinity, which is now upper limit, so it becomes minus infinity times 1 plus s all over 1 plus s all squared. So this is the upper limit minus the lower limit. Lower limit is what? 0. So wherever you see t, put in the value as 0. I have t exponential this, so t becomes what? 0. Okay, of course this becomes 0 times exponential. I have there 1 plus s times t is 0, so 1 plus s times 0 becomes 0. Everything that becomes 0. This is exponential 0 all over 1 plus s. Okay, this minus, same thing here. I have exponential 1 plus s times t there is 0 times everything that becomes 0, so I have exponential 0 all over 1 plus s all squared. And we'll be saying all along the series, exponential to infinity is undefined, hence everything here becomes 0. Same thing here, exponential to infinity is undefined, hence everything here becomes 0. Same thing here, this is 0 times exponential 0 times 0, everything here becomes what? 0. So I am left with what? This gave us 0, so let's put down our integral. Integral from 0 to infinity t exponential minus 1 plus s t dt, and this is equal to, so everything here gives us 0 minus here we have 0 as well, minus here we have, okay, here we have 0 minus exponential 0 is 1. Mind you, exponential 0 is 1, so we have here 1 all over 1 plus s all squared. Okay, so putting this now, 0 minus times minus becomes what? Plus. Hence, that integral from 0 to infinity of t exponential minus 1 plus st dt is now equal to minus times minus once again is plus, so I'm left with 1 all over 1 plus s all squared. So this is my integral, but not what I'm looking for. Remember, it's supposed to be 4 times that integral. So if you append this 4 now, this means that this now implies that 4 integral from 0 to infinity of t exponential minus 1 plus s t is now, okay, times dt is now equal to simply multiplying this result by 4. So we have 4 times 1 all over 1 plus s all squared. So this can be the answer, or you can simply say 4 divides. But whichever way, this is the answer, 4 times that, or you can simply write it as, of course, 4 all over this. So that becomes the answer to the given question. All right, so that's it on that particular question. I will see you in next video with another question on Laplace transformation. Thanks and cheers.